But a bad architecture is one thing. Where this gets truly terrifying is how these design decisions turned XML into an active weapon. How did that happen?
It all stems from a core design flaw from the very beginning. DTDs, or document type definitions. DTDs were designed to let you validate the structure of an XML file, but they also allowed you to define text macros inside the document itself.
And giving a document text macros effectively makes it Turing complete.
Exactly. If you want a passive, context-free data interchange format, giving it Turing complete macro expansion is the exact opposite of what you should do. That feature enabled the infamous billion laughs attack.
I've heard of the billion laughs attack, but how does it actually crash a server?
It uses exponential entity expansion. An attacker sends a tiny sub-1 kilobyte XML file. Inside the DTD, they define an entity, let's say the word lol. Then they define a second entity that calls the first one 10 times. Then a third that calls the second one 10 times.
Oh, no.
By the time you reach the 10th definition, you have a billion instances of a 3-byte string.
So the parser tries to expand it, and that 1 kilobyte payload instantly explodes into 3 gigabytes of memory, killing the server.
Yes. And when parser developers tried to get smart and look for deeply nested entities to block that specific attack, attackers just shifted their strategy to something called quadratic blowup.
How does that bypass the nesting checks?
Instead of nesting, you just create one massive 55,000 character entity. Then you reference that single entity tens of thousands of times in a perfectly flat document.
So it looks totally innocent to the parser.
Exactly. There's no deep nesting to trigger the security alarms, but a 200 kilobyte payload suddenly generates 2.5 gigabytes of memory.
Unbelievable. I've also heard of something called coercive parsing. How does that one work?
Coercive parsing targets the stack instead of the heap. An attacker sends an XML document with tens of thousands of deeply nested open tags, but intentionally leaves out the closing tags.
Oh, because the parser uses recursion?
Right. Because it uses recursive function calls to process tags, every open tag adds a frame to the CPU's call stack. Eventually, you hit the stack depth limit, and a stack overflow just brutally terminates the process.
So what does this all mean? It means XML violates the most fundamental rule of systems architecture. A data format should be passive. XML acted like executable code, and the industry paid the price.
And the most terrifying realization for any systems engineer is that none of these attacks rely on a bug. The billion laughs attack is the XML format working exactly as designed. The industry desperately needed an alternative.
Which brings us to the rise of JSON. Now, hearing how over-engineered and dangerous XML was, you would naturally assume JSON was meticulously designed by a team of paranoid security experts in a sterile lab. But I was looking at the origins of JSON. Didn't it start with a couple of guys just trying to make iframes work in 2001?
That is the irony of it. April 2001, Douglas Crockford and Chip Morningstar at State Software. They were trying to build interactive single-page applications, and they needed a way to pass JavaScript object literals via an iframe connection without using heavy browser plugins.
So they just needed something lightweight.
Exactly. And in doing so, they stumbled into the syntax that now runs the entire internet.
Let's talk about JSON syntax, because it has one very famous, very strict rule. All key names must be wrapped in double quotes. You'd think that was a grand security decision to prevent injection attacks, but that wasn't it at all, was it?
Not at all. It was literally just to stop a browser from getting confused. One of their early data packets used the JavaScript keyword do as an unquoted key name, and the browser completely choked because do is a reserved word in JavaScript.
So Crockford's solution was just, quote, all the keys, always. One single bug report forced a decision that became one of the most widely used syntax rules on the planet. Simplicity and security aligned entirely by accident.
It collapsed a parser ambiguity without trying to be a security feature. And the standardization journey for this scrappy little format reflects that organic growth. It starts with a simple memo, RFC 4627 in 2006.
Right.
Then ECMA 404 in 2013 formalizes the grammar. Then RFC 70159 drops the restriction that top-level items have to be objects, allowing just a raw array or string. Finally, in 2017, RFC 8259 mandates UTF-8 encoding everywhere.
But I have to ask about the one thing every developer complains about regarding JSON. Why are there no comments? You can't leave a single note for your team in a JSON file.
That was a ruthless, intentional decision by Crockford. He observed that developers were immediately abusing comments to embed proprietary parsing directives and routing schemas right into the data.
Oh, they were sneaking executable instructions back into the format, just like XML.
Exactly. They were trying to reinvent XML's complexity inside JSON. Removing comments was a move to preserve true semantic interoperability. He realized that if you give developers a metadata channel, they will use it to destroy the simplicity of the format.
That is brilliant. But JSON's scrappy, informal nature didn't just impact its syntax, it also impacted its legal standing, which leads to one of the funniest conflicts in open source history. You know, the no evil license.
Oh, I definitely do. Douglas Crockford took the standard open source MIT license for his JSON reference libraries, and he added exactly one line to it. The software shall be used for good, not evil.
Which sounds like a harmless joke.
But in the world of open source software, legal definitions are completely inflexible. That single sentence violated point 6 of the Open Source Initiative definition, which strictly forbids discrimination against any persons or fields of endeavor.
So you literally cannot ban evil in open source.
You cannot. Google Code banned the JSON license. The Apache Software Foundation had to move all JSON dependencies into their prohibited category.
And my absolute favorite part of this whole saga involves IBM. IBM's corporate lawyers actually had to call Douglas Crockford personally to get a bespoke, signed legal exemption because they couldn't legally use the software under that clause.
It's unbelievable.
Crockford wrote back saying, "I give permission for IBM, its customers, partners, and minions to use JSLint for evil."
And IBM's lawyers accepted it. It just highlights how organically JSON took over. It wasn't handed down by a massive corporate committee. It sneaked in through the back door of the web.